Good evening, good afternoon, and good morning from wherever you're joining us. Welcome to our webinars. So today we're going to be discussing the real-time implementations of the unified namespace in manufacturing industries. So my name is Kutsai Teresa, and today I'm joined by Alejandro and Jens. So I'm a senior industry solutions advocate here at HiveMQ, and my role really revolves around developing thought leadership material for topics such as the unified namespace. So this webinar is going to be recorded. So for all of you who are going to be requiring this recording, just watch out for your email inboxes, and also it's going to be published on our YouTube channel. And then we're also going to be taking your questions, of course. So please do use preferably the Q&A session. You should just avoid using the chat for your questions so that we could get to all of them. And then, of course, I'll let my co-hosts here introduce themselves. Jens, you want to go on?
Yes. Yeah, so my name is Jens Deters. I'm a member of the office of the CTO team at HiveMQ as a principal consultant. And similar to Kutsai, one of my major topic is unified namespace and real-life implementations of unified namespace. So I'm running a lot of UNS introduction and pilot planning workshops with our customers. I'm also creating educational material and enablement material for the HiveMQ University about different topics about all around MQTT and IoT use cases, but for sure also mainly unified namespace, which is really a very huge and important topic for us, and I see also for the industry these days.
And I'm Alejandro. I'm working at Mayker. We are a company based in Belgium that we are active in all kinds of digital manufacturing projects, and particularly in the last years in unified namespace projects. So I'm here to give the point of view from a system integrator about unified namespace and give a little bit my experience on the topic since we've been very active in this space in the last years.
Cool stuff. All right, so we've got a jam-packed agenda today. So we'll start with brief introductions here, and then Alejandro is then going to take us into an introduction into the unified namespace. For those of you who may not, be familiar with the concept, he's going to kind of like really break down for you. And then from there, he's then going to talk about his experience with a customer for like going through a path from POC to full unified namespace implementation to kind of like give you an idea of what that looks like for you in your case. And then after that, Jens is going to give us some MQTT best practices as far as how best to utilize MQTT for the unified namespace, what to look out for, what mistakes to avoid, and things like that. And then after that, we're going to take a look at use cases again from real customers from both Mayker and also from HiveMQ's point of view, all using the unified namespace. And then, as I mentioned earlier, we're also going to take some questions in the remaining minutes of this session. Yep. Okay, so just a quick introduction for those of you who may not be familiar with HiveMQ. So HiveMQ is a company based out of Landshut near Munich here in Germany. And we've been in operation since 2012. So we've really started out in the connected car industry, but we've since really addressed a wide range of companies in many different sectors. As you can see on the screen here, we've got companies in the pharma industries, we've got food and bev, we've got the automotive manufacturing, and also we really have got transportation also, as you can see here. So if you want to move to the next slide. Okay, just to give you a quick rundown of the HiveMQ platform. So HiveMQ really provides an enterprise MQTT platform, and the core of the platform really is the MQTT broker, which is what you see in the middle of that graphic there, which is deployable obviously as a fully managed solution or a self-managed solution. And the broker also consists of an extension ecosystem that allows you to sort of like connect all of your IoT data to backend services or streaming platforms. You think about it like Kafka, data lake, data warehouses, and also comes with an extension SDK that kind of like allows you to perform some level of governance or security mechanism for a unified namespace. And you could also build your custom applications for the platform. And then also Data Hub is an engine that allows you to perform data transformation on the data and the fly, and also perform things such as data validation. So this is all part of the core, MQTT broker product. And then on the left side, you see you've got the connectivity software, HiveMQ Edge, which is an open source connectivity software that also embeds an MQTT broker that allows you to connect to all your shop floor equipment, perform protocol translation into MQTT, and then integrate that into your enterprise MQTT platform. And also, of course, if you want to develop your custom MQTT client, we do provide client libraries, open source, of course, for .NET, Java, and so on. So, yeah, you wanna go to the next?
Yeah,
Okay.
I will give you now a brief introduction of Mayker. We're a company founded in 2022 in Belgium, and we are active in the Industry 4.0 sector. We are doing projects from initial assessments to implementation and ongoing support. So we cover the end-to-end process. And we've been active in unified namespace projects for a couple of years now, especially in Belgium. There's a very active manufacturing industry, and there's been a lot of progress in the last couple of years. We have a team of total already 50 experts, counting both employees and contractors. So it's a very fast growth for a company started in 2022. And we have offices now in the Benelux region, and we also have an office in Kosovo. Regarding our clients, we are active in different industries. So here you see some examples. We have clients in the pharma industry, building materials, a lot of food and beverage. Today I will be able to share some of my experiences working personally in some of these projects in food and beverage. But here you have a bit of an overview of some of our trusted clients. And now I'm going to give you just a bit of an introduction of what the challenges are that we see in the industry and in the IT/OT convergence. And we're going also to give you just a brief introduction of the unified namespace and how we see it fitting in this challenge. But to start with, as you probably many of you have experience in the manufacturing sector, in the industries, as they are industries that have been growing for many years, they carry lots of legacy systems, and these systems, as they expand or as they over the years they try to scale up, they start to integrate with IT with multiple point-to-point connections, which make architectures look something like in the representation here. And this poses some challenges, to put it lightly. So it's very difficult to integrate many systems in this way and to scale up the integration. And you can already start to imagine how HiveMQ or unified namespace could come through to solve these challenges. But in addition, this also gives us problems with data quality. For example, there are still lots of manual processes in the manufacturing industry, Excel spreadsheets with recipes and stuff like that. We also see lots of challenges with governance, which team is managing which systems, and how to manage this. This, of course, is also a security risk. There's a larger surface of attack and many point-to-point connections make it difficult to secure the whole networks. And as I was saying, scalability and complexity of the setup. And in this environment is where the unified namespace architecture starts to come in as a solution to these challenges. And if we start from the ISA 95 automation pyramid, we can see that most manufacturers start with this kind of architecture from the bottom up with different layers of the automation pyramid. But in practice, we see many connections between each of the systems that you see typically in an enterprise. So the MES systems are connected to PLCs, and they are connected as well to SCADA systems, to other equipment, to other sensors. We have a historian somewhere else, and a bit like we saw in the previous representation, this is a bit messy and complex. And unified namespace architecture tries to solve these challenges by offering a single point of contact that can connect to all the different systems and all the different equipment that we might have on a site or the whole enterprise. And the unified namespace aims to unify this data from IT and OT, providing the single source of truth. And it's a very scalable solution, especially when adding MQTT as a protocol, for example. And it also helps improve the data hierarchy. That's a topic that we're going to get more in detail later in the unified namespace best practices and MQTT best practices section. And it also helps drive business performance. And I'm going to show now how we, as Mayker, approach projects and how we go from a proof of concept or a proof of value to a full unified namespace implementation.
And just quickly also before you jump into the path to full UNS implementation, I kind of like want to sort of like emphasize on the core concepts of the unified namespace, just to get people to understand. I guess this is one of the key things that is often goes missed by a lot of people, to say, okay, the unified namespace. So as Alejandro mentioned, this idea of saying you want to decouple your sort of like legacy systems, you want to decouple your tightly coupled architecture and arrange your information in a semantic hierarchy. And the big really advantage of it is really how it enables you to be able to address multiple use cases, right? Because what has been happening for a long time is that when companies want to digitalize or digitally transform, they connect directly applications to your source systems, and then they remain stuck in that pilot phase, as it were, because you've got these direct connections. If you need to move on to the next use case, or you need to scale out, you need to stand out again all this connectivity infrastructure. So you end up having all this duplicate effort of setting up connectivity infrastructure for each and every use case, which in many cases you end up taking far much more time and far much more cost, and not really scalable for you to be able to address it. But the unified namespace gives you this idea of centralizing your data and then allowing to reuse the data, so you can move from one use case to the next use case at a significantly faster pace, and also at a much, much lower cost.
Mm-hmm. Yeah, thanks, Kudzai. Indeed, and how we approach the unified namespace projects or implementation of these architectures, we have a series of milestones in any project to allow us to go from initial assessment to full-fledged implementation. So to give you an overview of these steps, these are designed to allow us to do a tailored proposal for each use case, because every company is different and we need to adapt our approach in every case a little bit. But the general framework, in a simple way, it starts with ideating, knowing what we want to do, what is the project that we're going to work with. And then we start with mapping the current situation. Here we do some workshops and we start asking going into the end users, to the application owners at the different customers or at different parts of the company. What are their challenges? What are the current systems that they are using? And gathering all this information to map the current architecture and the current challenges. And then based on that, we can move to the third step, which is to design the to-be state. And that's where unified namespace-like architecture will come in, and we will be able to design something that addresses those challenges that we determine in the second phase. And the fourth step, once we have an agreed target architecture that we want to go through, is to design the sequential steps that we're going to follow to arrive to that end step. Once we have that, then we also choose the technology that we're going to use, like a HiveMQ broker. And the final step, of course, is actually executing this path with this technology. And to put this in a framework that also shows the maturity of the unified namespace, we also try to think or try to find out in the first phases of the project, in the as-is part of the analysis, where in this different maturity of the unified namespace, the client is at each moment. So we typically find that nowadays most companies are either in the bottom left with a standalone system, some IoT so IoT protocols, but the lack of standardization, or somewhere close to the first IoT integration. So we see that there's a little bit of movement and the start of some proof of concepts of with an MQTT broker to integrate data from different equipment. But we want to drive our customers from those initial stages to more advanced full UNS adoption, and eventually to a global vision with AI, machine learning integrated through the whole value chain. And this is the process that we try to follow. This is a very simple framework that allows us a little bit to place different clients in different places. And I'm going to show you now how, in a specific project, we approach the whole situation, and we manage to more or less place the current state of the client in this framework, and the steps that we did at each step of the way. So, well, first of all, regarding the rollout strategy, we start with proof of value and setting up broker, setting up the initial namespace, and then we start with scaling up. And the last step, of course, is optimizing and expanding. Regarding the use case that I was mentioning, this is something that I've been working on in the food and beverage industry. And this is a particular client that needed a scalable architecture that was using the unified namespace architecture to enhance security and also improve the operational efficiency and eventually drive future AI and machine learning integrations. So this was the typical case showing all the challenges that I was presenting before. The as-is situation, as we mapped it at the beginning, was that we saw multiple connections between shop floor, SCADA system, the MES layer. They had a historian also. They had some connections to a cloud data lake. But this was done via the traditional expansion, where when a business user needed some data from some place, someone from the automation team was able to set up a connection, and then they were, okay, here you go, now you have some data. And this is a typical situation that we see in many clients, and you probably have seen it as well. And okay, this, as we were saying before, it poses some concerns for scalability, also for security. And the conclusion is that we needed a more resilient IT/OT architecture with a robust governance framework also, and also to address those security risks. In conclusion, to be set up was to implement unified namespace architecture. And also something interesting that we that we implemented or that we started building is an IT/OT team that was responsible for carrying in this process. So it's not just we also made it clear who was the responsible of implementing this project and then maintaining also the new architecture. And in this case, we also used HiveMQ Cloud. And to give you a little bit of an overview of the steps that we followed at each step. So as we started, we were here in the bottom left, some standalone systems that were using MQTT actually to send data from SCADA to the historian, for example. But there were no common standards, no security, and some security concerns. And then we moved to the first step, the IoT integration, where we set up the first proof of value, HiveMQ concept, UNS integration with SCADA from one production line. Then the second step, after the proof of value, was to integrate also historian and then prove that with the HiveMQ broker, we could manage the volume of data that was necessary. And then we started scaling up. So at the end of this first stage, we had an enterprise HiveMQ broker, fully functional, integrating data from just the SCADA system from one side. And then we started onboarding data from other systems, not just SCADA, but other equipment, other MES applications. We added edge computing to collect and perform aggregations on the edge, for example. Also, for example, we were able to integrate some computer vision systems. So that was very, very interesting. And we were also able to integrate eventually with the ERP system. Now, the future vision is to also perform AI and machine learning at scale and drive data-driven operations across the whole enterprise. So that's really the next step, what we're aiming for in the future. But I hope this gives you a bit of an overview of the different steps that we followed and that we think are the correct approach to tackle these challenges.
I think before we move on to the next step, I think while we're here, we could as well address this question because it speaks to what you're showing currently on the screen. So there's someone who's asking about how you sort of like, what about transactional data from systems like ERP? Do you still connect that to the unified namespace? Do you want to answer that one quickly?
Sorry, say again.
So basically, they're asking do you still connect ERP data to the unified namespace?
Yes, we do. So the data or some data from the ERP is available from the unified namespace. So I'm not saying that necessarily transactional data should be going only through the unified namespace, but it's definitely valuable for some use cases that the data or from the ERP is available in the unified namespace or in the HiveMQ broker, so that other clients are able to access that data and, for example, report or perform some other calculations. Yeah, it's definitely something that we do.
Yeah, in the next part of this session, I will also have some examples of how to integrate an MES on an ERP system into an UNS topic tree. And with that, let me go for the for some words about best practices and what to consider when designing a unified namespace, topic tree, and hierarchy. Foundation of a unified namespace is actually the MQTT protocol, because it's technically such a great fit in all the requirements that needs to be fulfilled in order to create a real-time a data hub that reflects everything what's going on in your enterprise at this moment. And using MQTT for implementing a unified namespace leads up into talk about topics and also payloads. So first of all, what you should have in mind when you're creating a MQTT topic hierarchy is that the topic should contain information for dedicated routing and filtering. It should not contain the data. The data is actually part of the payload. If you have a good topic structure, this is the foundation for effective filtering. Basically, a good approach, and what we've also implemented in our projects, and what we see what's really helping the industry, especially the manufacturing industry, to implement a unified namespace is to follow existing specifications, mostly the ISA 9.5, or maybe also Eclipse Sparkplug. But to be honest, Eclipse Sparkplug is not the best approach to implement a unified namespace for the whole enterprise. It can be part of the UNS, but the UNS is more than device management and focusing on the shop floor and the automation.
Yeah, I agree on that, and also I would add that Sparkplug adds some complexity sometimes that might be difficult to manage.
Yeah, also Sparkplug defines a very rigid topics hierarchy and topic guidelines. So that's a major complaint about Eclipse Sparkplug that makes it really complicated because of this rigid defined topic structure.
But we do have the two namespaces coexisting in the previous example that I was sharing before, actually.
Yeah. Okay. The structure and the hierarchy. If you're starting with the defining your topic hierarchy and your structure, you should go for really a logical structure that reflects your organization or your system architecture. Keep in mind that the unified namespace is meant to show your real-time data in your enterprise. So if you're following this approach with broad categories and then get more specific, so like this is an ISA 9.5 like structure. So start with the enterprise, then go down with your specific production site, your production area, your line, your work cell, and then go down for the equipment and the specific data types that are provided, like status or temperature or humidity or work order or something like this. So this is how you should start, and this is also how we are doing it in our projects. So as a tip, you should start to define your namespace to set the context. For instance, you can if you are going for the ISA 9.5 strategy, and then you start with the enterprise. That is basically your company name or your brand. This sets the context of the unified namespace. This is reflecting your organization. What's also a good approach, especially if you're starting designing your unified namespace, and you might where it's really likely that you have future modifications on your namespace, you can introduce a version This is commonly used, for instance, or in a REST API. You're introducing a version tag in your topic structure. So in this example, you're starting with your enterprise to set your context, and then followed by the version, and then there is the rest of the ISA 9.5 topic structure then. So if you're this is generally, this is not only for a unified namespace. This is generally, if you're designing MQTT topics, you should not start with a leading slash. This is often seen, especially when people are starting with MQTT. This feels kind of natural because you're defining the root of your structure, like on your file system, in a Unix file system. But this, you should really avoid this when we're dealing with MQTT, because every topic in MQTT always starts with a topic level, and if you're starting with a leading slash, there you're introducing an empty string as the first level. This is really unnecessary. Yeah, you don't need that. You should avoid it. Next thing that you should avoid is using metadata in topics. Metadata like IDs or timestamps. This should really be included in the payload. Or if you're using MQTT 5, it's a good approach to put your metadata in the header as user properties. This is yeah, kind of like more effective than to put it in the payload if you have the chance with MQTT 5. But definitely you should not include this information in your topics, in your topic structure. So there is an exception. Sometimes it makes sense to include meta information like the client ID in the topic. We are using this, for instance, in connected car use cases to really identify a specific car by its vehicle identification number. But especially in a unified namespace, which lives for the whole enterprise and anyone, or there are a lot of different stakeholders that want to access this live data, then yeah, metadata in topics is not a good way. Next is you should avoid key value pairs in your topics. This is also another thing that we see a lot of times when people are starting with MQTT. So like this temperature and then the temperature value, or status, and then the status, the online or offline status. So if you're using key value pairs in your topic, you're really it's very easy to blow up your topic structure and your topic tree with basically no effect. So this really leads into unmanageable huge topic trees. You should really go for setting the value like status or temperature in your context of your topic, and then use the payload for the actual value. Next thing that you should definitely avoid is blanks in your topics. This is a true source of error and typos, and also blanks can make it very complicated to parse a topic. Also integrating web technologies, if you're using web technologies in your IoT systems, you may require encode these %20 value. You should go for underscores or dashes. Please avoid blanks in your topics. Next thing that is also a very good approach is to avoid uppercase letters. This is the next risk of mismatched topics and typos. You should avoid these camel case kind of naming, and you should go for a snake case, so with these underscores as a delimiter of words. And you should please have in mind that MQTT topics are case sensitive. Therefore, it's really easy to introduce a typo when you're using uppercase letters. So always lowercase as a normalization. That is a good approach. And in this context, you should also avoid ambiguous terms. So you should really introduce a consistent naming convention, and that can be very well documented. And you should enforce these conventions with your different teams and business units in your organization. So everyone follows the same practice and the same approach. Who is taking part of the unified namespace. So in here I have some examples and some ideas of how to map the different levels of ISA 95 to topics. So it starts with the physical processes on level 0. So, for instance, you have then, as a common pattern here, enterprise site area production line, and then machine and sensor. And for instance, for a temperature, this is an example of how the payload could be structured as a JSON in a JSON format. So next level is level 1, the equipment control. Then there you're introducing the next level after the machine, the specific machine. You're introducing the controller definition, and then also different parameters like status or a command topic, where you're able to send commands to a controller. To introduce its or to modify its behavior. Next level is level 2. So the SCADA systems, the alarms, and the event systems, also represented by is a SCADA topic level, with alarms and metrics. MES data can be introduced on a higher level for specific production line, for instance. And then you're introducing your MES topic level, and this is a brief example of how a work order could look like. I'm pretty sure in a real production system, the work order is more blown up, but so this is really a very simple one to create the quantity of 500 for the product widget A. And as a last example, here is the ERP level data for inventory, for schedules. This goes probably not only for an area or a production line. This goes for a whole site of your organization. So this is an example how ERP level fits into the unified namespace. Okay.
Yeah. In this section, we're going to go again through some more details of different use cases that we've worked on. So I think I have 2 examples, and then we have 2 examples that Kudzai is going to present. By the way, regarding everything that we're discussing, if you want to know more details, feel free to reach out, and I'll be happy to attend your needs and try to give you further details after the call if necessary. But here again, talking in general about the food and beverage industry, the challenges that we see are, like we were saying, the end-to-end IoT architecture missing, the lack of governance structures to manage these systems, and scalability of the data collection systems. And it's important to think of this project as use case driven. So we want the end users of the data, for example, to reach out and say we need to access data from that specific system to display it in a dashboard in real time, or to perform some analysis to drive the training of a machine learning model. But we try to work in this way, where we have a use case first, and then we work with the end user to realize that use case. And unified namespace, or HiveMQ, is the tool that we use to drive this use case and make it possible. But it's not the other way around, that we first set up everything and then we wait to see if someone uses it. It's important to be use case driven, to drive value also, so that from the beginning we are able to generate value from all this work that we are doing. In particular with food and beverage, one of the use cases or challenges that we found is that in many times, and many of these clients, they are planning to build new greenfield plants in the future, and they want to start these new plants already with a prepared unified namespace structure and architecture that they can start using from day one. So it's also one of the big benefits of having a scalable architecture that you are able to implement in a new project like that. And it becomes much easier, of course, when you have a well-documented system that shows you what steps you need to take to implement this structure. And the solutions, like we were saying, we use HiveMQ in many of our projects. We also use edge computing solutions like the HiveMQ Edge. And the typical case also is to integrate HiveMQ with cloud data pipeline, in many cases via the Kafka extension, for example. So to Azure Event Hubs or to Confluence Kafka, and MES integration, very typical use case. In a second category of use cases, let's say, that I think are worth mentioning, are connecting remote assets. So besides our typical SCADA or historian, many times we work with devices that are in remote locations, in the fields, vehicles, or something that is not so easy to integrate into the architecture. And here is where things like HiveMQ, the unified namespace, can also be very powerful. So we are able to provide real-time insights for these use cases thanks to this architecture. And we've worked on this with different customers also, implementing unified namespace architecture to access the data from systems that are typically not connected to the rest of the IT infrastructure. So it's important also to standardize the data flows across these locations and connect these devices from the legacy systems to the central UNS. And at the end, this allows us to enable the real-time data collection from all these systems. These are 2 examples that I wanted to mention here. And if you have questions, you want to know more, feel free to ask. And maybe in the Q&A, we can go through some other examples. But now I give the word to Kudzai to give a couple more use cases.
Thank you, Leandro. Yeah, so to kind of like close this off, I want to highlight two use cases of companies that are using HiveMQ for their UNS implementation, just to kind of like give you an idea of what that looks like. So these use cases are actually case studies that are available on our website. So if you really want to sort of like read about it in detail, please feel free to go to our website and find out more. So the first company that I want to highlight here is Eli Lilly. So this is one of the largest pharma manufacturing companies in the world. So basically, the scenario is that they have like a lot of instruments for a lot of production and testing and measuring that they discovered is not really connected to centralized computer systems. So as you can imagine, obviously, in just like in many highly regulated industries, that provides a challenge as far as adhering to some compliance standards, which requires all of this data to be collected. So as part of the efforts to sort of like close those connectivity gaps, Eli then took this approach of implementing the unified namespace through what is called an equipment connectivity platform, which is a platform they really kind of like designed to be able to integrate all of these different systems, which include MES system, your laboratory execution system, and so forth. And as part of that connectivity platform, they were using also standards like Sparkplug. I think we spoke about Sparkplug, where it's useful, where it's not. You find a lot of companies that are utilizing it at one aspect of their architecture, and then also kind of like maybe into the unified namespace architecture. And then they also leverage Kafka, the connectivity interface that HiveMQ provides to connect that information to Kafka. And then, really, as part of that effort, they managed to connect several hundred of instruments across many different laboratories, across many different sites. And then they're now able to do automatic data capture and then be able to present that in a semantically accessible, centralized repository of information, which is a unified namespace. And then they're able to then meet their regulatory requirements. And as a result of that, they do have this standardization of data across multiple sites, and they've effectively reduced the manual data collection and also the paper processes that they've been using before. If you want to move to the next one quickly. Yeah, so the other one that I want to highlight here is Anglian Water. So Anglian Water is the largest water and wastewater recycling company in the UK. So as you can see, really the unified namespace is applicable not only to manufacturing, but in kind of like, use cases where you've got this distributed network of wastewater treatment plants and water facilities. So this is the case here as with the Anglian water. So basically, the challenge that we're having here was really, meeting the customer requirements, right, and also making sure that they adhere to the environmental performance and also just the operational efficiency that they didn't have, as due to the lack of visibility into the data. Data was logged in different systems in all these different treatment plants, and they wanted to sort of like bring this all into a single source of truth where they're able to then perform all the different use cases that allow them to address customer service, operational efficiency, and so on and so forth. And then once they had implemented that unified namespace, they were then better able to get some insights into asset performance. And then they really significantly improved the integration of data between their OT and IT environments. And then also, I mean, as Alejandro mentioned, one of the big advantages of unified namespace is this security that it brings into a system, which in this case, it allowed them to maintain that high level of security. So as I highlighted, these use cases are available on our website. So if you want to really get a much deeper insight into exactly how these companies implemented their unified namespace, feel free to check those out. So we do have many questions, and it's a good thing that we've got a full 10 minutes to trying to get as many of your questions as possible. So I'll quickly jump into the Q&A here and I think we have already answered this one about ERP transaction. So there is a question from Daniel. So Daniel is asking, is there a concept 2.0 for going behind your four walls, simplifying connectivity with customer and vendors? Alejandro, you want to take that one?
Yeah. Yeah, I was looking at this question, and indeed the last step of connecting customer with vendors, and that's kind of the ideal future where customer directly poses an order, and then that data is fed into the UNS, and immediately the production order is generated in the full flow is automatized, and you end up having the product produced just by triggering the order. That's I would say the something included in the last step of those four steps that we defined before. But of course there's a lot of work to do to get to that point, and yeah, we're working on it. Of course, I think that's what this means, the concept 2.0 mentioned here.
Oh, yeah, absolutely. So we've got a question from Yannick. I think we've touched on this one, but just quickly, they're asking how to integrate ERP, how to integrate with ERP system for the unified namespace. So maybe I could just kind of quickly emphasize the points that you mentioned. So really, ERP system, you want to integrate your production orders into the unified namespace. So obviously, as you know, ERP is a transactional system. So what you do need to have is to have some form of IoT platform or some proxy that is able to listen in on the transactions and then publish those as events into the unified namespace, right? So now you've got your production orders that are published as events into the unified namespace, and then your MES system is subscribed to receive all of this information. And then when your MES system performs and tracks the work orders, it then publishes those results back into the unified namespace, and then the ERP system is able to get those, production responses as it were.
If
And
I
then
can
there's
add something here, yeah, could I I would like to stress the point of having a use case, integrate the ERP as a whole. I think that we need to break it down into smaller chunks. Like, for example, do we want some data from the ERP, like production orders, to be integrated with computer vision application that needs that information to run and to provide some quality analysis on the product. So that's a specific use case where we need some ERP data fed into the UNS to complete the use case. But yeah, I think it needs to be done in this way, where for each use case we might need some data from the ERP, and then we see what is the best way to integrate that ERP data into the rest of the unified namespace.
awesome. So the next question that we have is, how do you manage historic data access and relationships in UNS? You want to take that one, Alejandro?
Historic data access and relationships in UNS. It's a difficult question because the unified namespace, or the data available in the broker at any given time, is the real the latest state of your system, is the latest value. It's not the historical data, right? So if I'm understanding this correctly, we are talking about the historical data that might be stored in a time series database in the historian, and we need to and it's a question about how to manage the relationships between this data. But in the UNS per se, we are not managing those relationships and that historical data. That's something for that can be done in the historian database, or in another data analytics platform, I would say.
Yep, absolutely.
What you can do in addition is for instance, create services that calculate aggregations. So the last 24 hours, the last week, the last month, this year. And this is frequently updated and then published to specific topics in the UNS have the option to react on these kind of aggregations and data.
Awesome. And then the next one here, I think this one is for you, Jens, because I think we get this question a lot also maybe during our workshop that we do with customers. So where do we define the structure and hierarchy of the unified namespace? So this is Anaban was asking this to say, where is that defined? Where is the structure defined?
The definition, basically, if you're using MQTT, you are defining your structure by publishing or subscribing to topics. So this will need a lot of coordination in your organization. You have to get together with all the stakeholders and everyone who is participating to the UNS, and then you're defining the kind of data you need to access and you want to share in the UNS, and then you have to agree basically on a structure and a hierarchy, how you would organize your hierarchy, and then you need a proper documentation about this that is shared with everyone who's participating. So
Okay.
in MQTT, on an MQTT broker, you don't have to, or there's basically no way to ask the broker for all current topics, and you don't have to predefine the topics in your MQTT broker. So topics in the broker do exist by usage. They are dynamically created.
Great stuff. Okay, so if there's another one, Alejandro, that you identify that you want to answer quickly.
Yeah, I was going through some of these questions. I see a couple of them about the spark plug. We discussed a little bit before about the complexities in spark plug and but in general, yes, the spark plug and the plain MQTT namespaces can coexist, and they do in many cases, and there's nothing wrong with that. Something I would like to mention also is that we use the HiveMQ data hub sometimes to convert Sparkplug messages into MQTT. That's a useful feature, and we use it a lot to convert to communicate with non-Sparkplug compatible MQTT clients, for example. So if you receive a Sparkplug message, but then some of the data in that message needs to be provided to a client that is not Sparkplug compatible, using this feature in HiveMQ, you can transform that payload into a message that then you can provide to a client that is not compatible with Sparkplug.
Great stuff. I think we've got a slot for one or two questions quickly. So I think there's a question also that was saying, why not use OSI Pi for UNS? So maybe I could quickly just, talk about that. So the unified namespace is really based on this, open architecture, right? Where you, first of all, change-based notification is one of the things that are core to the unified namespace, which is not available with the OSI Pi environment. And also, since this is like your central, the OSI Pi still exists within the the overall architecture. So unified namespace is not a replacement for OSI Pi, but is for your real-time data access, and then all through that open architecture with MQTT. So also within the unified namespace, you're able to structure the data, however you want to structure into like a complex information model, which is something that, a lot of historians don't typically, present data. In most cases, it's always your key value pairs. You've got, this is your tag, this is your data, this is your timestamp, right? But you want to be able to create these complex data objects. And then you also want to, access it through that, open common endpoint and not, SDK or proprietary interfaces that you may have to use to access data from a historian. And obviously, since this is like your single source of truth and your single point of failure, every other system needs to access it. So you don't want to create multiple applications from the IT side going down to your historian and accessing the data by creating dedicated connections. Rather, you want to have this decoupling architecture and not have one system be the center of everything.
Yeah. If I can take one more question, could I?
Yes.
I see here a question from Rini about setting up topics. If the examples provided by Jens are aligned with my experience, I would say yes. But I wanted to mention that it's also important to see in each case, in each client, what is the best solution for them. So there's no one size fits all. There's always something that might need to be adjusted for specific case, for a specific client. And we have here a framework with some some guidelines, with some best practices, like lowercase letters, the snake case, the avoiding the slashes, the spaces. So that's all really good best practices. But it's important to keep in mind that each case is different, and in some cases the general guideline might not be the best case for you, and then it's better to do something that really works for you and not try to adhere to some standard that might cause additional problems. So just keep that in mind.
Yeah, definitely. So that if you're going for a unified namespace, there's not a final industry standard specification that says you have to do it this way. Then it's called a unified namespace. At the end of the day, it's about using MQTT for showing your that's the idea, using MQTT to reflect your real-time state of your enterprise, of everything that is going on.
Awesome stuff. So with that, we've unfortunately run out of time and we've come to the end of this session. If we didn't get a chance to go through your questions, we're always happy to address these ones with a follow-up email. So please do feel free to reach out to us and we'll certainly be able to help. So thank you everyone for attending this session, and thank you to our panelists. And until next time, have a good time.
Okay, have a good one.
Bye.
Bye-bye.